All right, so this is a continuation of our lesson from yesterday, 6.3. I did upload 6.3 late last night yesterday, so hopefully you were able to see that. So we're going to start with where we left off last time, which is graphing these exponential functions. So the first thing we want to identify is our parent function. What's our parent function? Yeah, 1/2 to the x. Perfect. Our parent function is 1/2 to the x. Remember the a value. What's my a value? -1. My a value is -1, and that affects the graph how? It reflects it. Excellent. So we know we have a reflection here. The a value also tells me my y-intercept. What is my y-intercept? 0, -1. Right. Which makes sense. If I plug in 0 for x, anything to the 0th power is 1. And then with my order of operations, I take care of exponents first, so 1/2 to the 0 is 1, and then I add that negative. So it makes sense that my y-intercept is 0, -1. All right, reflection over here. Now as far as graphing, we just said we were going to make a t-chart, and that's what we're going to do. That's all it takes. X, y, and then you just want to plug in a few values. We're going to stick with our standard -2, -1, 0, 1, and 2. Again, we use those values because it lets us know a couple of things. It lets us know what's happening at the origin, as well as a couple points to the left of it and a couple points to the right of it. At this point, it's just a matter of making sure that we can evaluate correctly, we remember our signs correctly, etc. So I'm going to find f of x whenever I plug in -2. So f of -2 equals -1/2 to the -2. How do I change that -2 to a +2? Yes. Yeah, I look at the reciprocal. So when I'm evaluating f of -2, all I do is I put it in the denominator. I still have a negative out front. That doesn't change. And I have a 1/2 squared. According to my order of operations, what do I do first? Yes. I take 1/2 and I do what with it? What does it say? I square it. Right. Remember exponents first. So when I square that, I get 1 over -1/4. What's that equal? Yeah, -4. Right. If you don't know that, then you can just say, how do I divide a fraction? How do you divide a fraction? You flip and multiply, right? Does that make sense? So on the test, the problem that I foresee happening, because it's happened before, is you identifying the parent function, you identifying the transformation, you identifying the y-intercept, and then kind of getting confused about how to plug in the x values. All you're doing, don't overcomplicate it. All you're doing is you're plugging in -2 for x and so on. You have to remember your rules of exponents correctly though. That's the one thing. So do take your time with that. When you plug in -1, make sure you're plugging it in correctly. You're going to get a +1, so you're going to have to bring it to the denominator and then remember the negative, that kind of thing. So when you look at your test, don't get to this part and get confused. You know what to do. You're just plugging it in, and then you have to remember your basic rules of exponents. Does that make sense? Once we're able to do that, we can simply finish the rest of our chart. And really, is there a simpler way to do this rather than plug in each individual number? Can you maybe plug in these three and then know automatically what the rest will be?
You just do one side and you flip it, get a reciprocal, you get the positive or negative.
That's play. What do we know about exponential functions and the y values changing? We talked about the x values going up every time, increasing by a constant amount. What do we say is true about the y values? They are being multiplied by a constant what? Ratio. What's the constant ratio here? Yeah, they're multiplied by 1/2. Does that make sense? So you don't have to plug in every single thing and work by hand. That'll take a long time. Once you see that constant ratio, once you identify that constant ratio, then apply it. Okay? You know that you're going to be dividing by 2 every time. Okay? Does that make sense? All right, I apologize for viewers watching. Okay. Well, I'm going to go ahead and erase this and then wrap it. Any questions about that? Remember that shortcut. It will save your life on the test. Okay? So now we just plot those points. Okay. I'm going to go by ones. So make sure you let me know you're going by ones. I'm just going to indicate a couple points here. And then I'm going to graph. -2, -4. -1, -2. 0, -1. 1, -1/2. And 2, -1/4. You have a smooth curve. Now, the reason it's not going to go around in a loop is because we don't have a function next to it, right? Is that a function? No. So if we're graphing an exponential function, it's going to look like this and just keep going straight to the right. Okay? Does that make sense? So, domain and range. What's our domain? All real numbers, right? All real numbers. Close. All real numbers. And then, what is my range? Yeah, y is less than 0. Perfect. Do you have any questions? Yes. Domain, you look and you see the graph. You have 2 arrowheads, right? And then you look at the x-axis. Domain is x's, right? You move along the x-axis and you ask yourself, is there an x value on this line for every x value, right? So if I continue moving, right, 5, 6, 7, 8, that'll all be on this graph, right? If I keep moving down, the same thing here. You'll find -6, -7, -8. That'll be somewhere on this graph, just at the very bottom, perhaps. Does that make sense? Yeah, when you see 2 arrowheads like that, that's an indication you'll have all real numbers. Okay, any other questions? All right. Let me pause this. Okay, so if you're watching, make sure you pause and try this. We talked about the basic shapes of your exponential graphs here. Notice that the 4 means that it's going to go from the left to the right. The fact that it's reflected means that it's going down from left to right. The 1/4 means that it's going to go up, but instead of going left to right, it goes right to left. And I want to emphasize something that I don't think I emphasized before, and that is what more that b value does. So we know it tells us the direction. It also tells us a little bit of a shortcut. That 4 and the 1/4 tells us exactly that constant ratio that our y values are going to go up by. So for example, if I was looking at one point, let's say I was looking at 0, so this is another shortcut. So these should be actually pretty quick, these tables, and I'll tell you why. If you plug in 0, what do you know you're going to get automatically? -2. You know that's your y-intercept because that's your a value, right? Well, according to this, your y values are going to go up by a constant ratio of what? 4. Okay? So what you should have done is you should have said, okay, when I plug in 1, what's my next point? Shouldn't it be -8? How did I get -8? How could I go to -8 really quick? Yes. Yep. What's my next point? Yeah. Does that make sense? That's very quick. And I just realized I didn't tell you that. That's very quick, right? So hopefully, when you're looking at points, really what you need to know, this tells you a ton. So hopefully when you graph these, you got something like this. The take on this shape. Okay, again, we knew that it was going to look like that. And I'm going to read to you what it says. It says the graph of f is a vertical stretch by a factor of 2. So we're describing how it differs from the parent function. So it's a vertical stretch of a factor of 2 and a reflection in the x-axis of the graph g of x equals 4 to the x. 4 to the x is our parent function, right? So it's stretching by a factor of 2 and it's reflecting. Then it tells us the y-intercept, which we said is -2. And then it tells us the domain, all real numbers, and the range, y is less than 0. Do you know that? Excellent. And then the same is true for the second one. It's a vertical stretch by a factor of 2 of the graph of our parent function 1/4 to the x. Do you have any questions about those? All right. Go ahead and copy down what I have there, and then we're going to talk about it. We're going to take a look at translations. What if our exponential graph is moved to the right or left? We remember h and k from our absolute value, right? And the same is true here. What do you suppose the h tells us? Does that tell us it's going to move left or right, or up or down? Left, right, up or down? Any idea? Well, last time when we talked about absolute values, we had a times x minus h plus k. Good review for the final. H said we were moving what? Left to right. Well, the special thing that we have to remember about the h, the sign of the h. Yeah, if it's a positive, you make it negative. If it's a negative, you make it positive, right? We also knew that k told us up and down, and we could get our vertex, hk. Remember all that? The same is true here. This is going to tell us to move, what do you think? Am I going to move left 3 units or right 3 units? I'm going to move right 3 units. Remember, h is, anything that's attached to our h is, that's going to be the opposite. So I'm going to move right 3 units, and I'm going to move what? Up 2. Right. Right 3 units and up 2 units. So I want to be able to make that transformation over here. Well, all it takes, and it's a lot simpler than you might think. All it takes is graphing the parent function without any transformations other than the stretches or shrinks, right? So without any horizontal shifts or vertical shifts, any movement left or right or up or down, and then apply. So what I mean by that is, forget about the -3, forget about the +2, graph that 4 to the 2x. Well, it's something that we've graphed before, but again, what do we know is our y-intercept right away? 4. Okay, what's going to be the next point? 8. What's going to be the next point? Okay, what's going to be -1? 2. You divide it, right? What's going to be -2? 1. See how quick that was? Now, what do you think you're going to do for your next one? What's going to change? How are you going to change x? Not the sign. This says you're moving what? Right 3. So what do you think you're going to do to all your x values? You're going to add 3, right? So you're going to add 3 each time. So what do you get here for your first x value? You're going to add 3 to -2, so you get what? 1. What about the next one? 2. What about the next one? 3. Next one? 4. Next one? 5. Yeah? What do you suppose you're going to do to all your y's? Add 2. Right. So what's your first y? Next one? 4. Next one?
6,
Next one?
10,
Next one?
8.
You have your points. Does that make sense? And you just plot them. So it's a lot easier than it probably looks, huh? So, do you have any questions on that? Now, when you graph it, let me show you the graph. You can see the difference in the blue. So we knew right away with our original function without any shifts, we had 0, 4 as that intercept. And that 0, 4, that changed to 3, 6. And 3, 6 is right here. So you see how that shifted over and up? And that's what's happening. Does that make sense? How will does our domain change? No, our domain is still all real numbers. Does our range change? Yes. What is our range? Y is greater than, they're going by 2's. So y is greater than 2. Right. You have what's called an asymptote here. Okay. That means that it's never gonna have like this invisible little horizontal dotted line, which means it's never going to cross it. It's going to get arbitrarily close, closer and closer and closer and closer. It's never actually going to hit the vertical line. It looks like it will, but it won't ever. It'll get extremely close, but it won't ever. So here, y is greater than 2. Do you have any questions about that? Excellent. All right. Okay, so with this modeling question, it says, write an exponential function that represents the population, find the population after 12 hours and after 5 days. So we know that our exponential functions take the form y equals a, b, dx. You should always be able, from this point on, to look at a graph of an exponential function, and tell me right away what the equation is that goes with that graph. And the easiest way to do that is to make a table of values. That's what they did here. They gave you all those points, so you want to list them out. When you list them out, you want to find that constant ratio. And the constant ratio is what? 4, right. And we're going up by what each time? 1. So knowing what you know about constant ratios, about the y-intercept, well, for those of you watching, a bird just okay, well, Tuesday. Anyway, so, all right. Okay, momentary, okay, so, based on what we talked about previously, what do you think the equation is going to be? What's going to be my A value? What's going to be my A value? If you get this, I'll be really happy.
Your A value is going to be
3. 3. How'd you get 3? It's the what? The y-intercept.
What do you mean? Oh.
well, I said 200.
What's going to be my B? 4. Right. Where did you get the B value?
From the times x2.
Times
That's
4. Times 4.
Yeah.
So there we go. That's our, that's what models our graph.
That's crazy.
Mind blown. Okay. Well, now we actually, so we found A, it represents the population. Now it says find the population after 12 hours and after 5 days. What's the problem with B? Are they the same units? No. 1 unit is in what? Hours. 1 unit is in days. Based on our graph, what are we going to change? Are we going to change the days to hours or the hours to days? Hours to days. So 12 hours is how many days?
Half a day.
Half a day. 1/2 a day. Okay? And then we're just going to plug in, right? So after 12 hours, we're going to plug in 1/2 for x, get 6. And after 5 days, we're going to plug in 5 for x, and get 3,072. So there are 6 bacteria after 12 hours, and 3,072 bacteria after 5 days. See how rapidly that grew? That's why people get sick. Okay. Do you have any questions, or do you feel pretty confident about this now? Good. Okay, I was going to have you work, like practice one, but I'll just give you the homework. Here's your homework number 7. Here's your updated table of contents.